And welcome everyone. So let me start with an outline of our webinar today. We will start with an overview of the current security landscape and our vision about the next frontier. Then we will share some details about our upcoming product offering, Agentic AI Red Team Engine. That will be followed by a demo. And then we will go over the security benchmark bake-off that we did recently. And we will recap the key points and have a Q&A. So with that, I'm going to turn it to Pierre, my colleague.
Yes, thank you, Hom, for the introduction. So let me set the stage. Okay, so software is shipping faster and getting more complex. We all know that. And this is creating a vast, constantly shifting attack surface. So the problem is the manual validation just cannot keep up. And current solutions like automation can close part of this gap. And we see examples like a platform like Reachbot can provide the validation that we need at scale. But the next leap is not more automation, it's autonomy. So the need of specialized AI agents that can reason, plan, and adapt in real time. So the power here comes from combining the automation speed and broad coverage with expert level insight that before only human could have. So the agent can find complex attack paths and surface risk before attackers do. So the next frontier is moving from faster checks to smarter autonomous validation. So before digging into our agentic framework, let's start with some basic definitions. So at the foundations, we have the large language models, right? So the LLM provides a general purpose reasoning engine, and it's trained on massive amount of data. It provides broad, adaptable intelligence. In the next layer, we have domain-specific language models, like the SLMs. And these are specific LLMs which are trained on specific fields like cybersecurity. They can enable high accuracy, more actionable insights, and they come with the benefits of specialized models. So we can have greater efficiency, smaller resource footprint, a flexible deployment if you want. You can deployment on premises. At least these are the key takeaways and messages of Gartner 2025, which thinks that DSLM are set to shape the future of security operation.
Pierre, we see the adoption of DSLMs continues to grow. Do you think that the upcoming innovations in the market will involve DSLMs a lot more than LLMs moving forward?
Yeah, thanks for the question, Hom. I mean, I think in overall, DSLM, generally speaking, is like basically an LLM which has been fine-tuned. And although this can provide advantages, as we've seen with greater efficiency and so on, but it's not always the best solution for the problem. And recently we've seen, especially from both from the industry, like Jensen Huang in NVIDIA, but also in academia, like Professor Jan Stoga at UC Berkeley, have been shifting the focus from fine-tuning LLMs to building an operating system around it. So this domain knowledge that we talk about with the DSLM doesn't have necessarily be baked inside the LLM knowledge, modifying the way it might not always be the best approach, because as soon as the new LLM comes out, you need to fine-tune and then what are you going to do with your knowledge? Instead, it's better if you build memory and orchestrate your strategy around the LLMs. And so this is the concept of building an operating system that I was mentioning before.
Very good, thank you.
Okay, moving forward. So how do we go from the LLM, the models, to the agents? So at the core, an agent combine the LLM or DSLM with three core elements: a defined purpose, so goals. Then we have a state, so memory when we need, and the ability to use tools. So these capabilities can progress through different levels of autonomy. And we can think about the level of autonomy in cybersecurity like different level of pen testers. For example, level 1, where we have the LLM combined with goals and tools, this can act as a junior pen tester. So it can perform a sequence of actions, and it's ideal for rapid discovery and basic checks. Then as we add memory, so at level 2, we can start planning and multi-step strategies. So the agent can adapt based on previous outcomes, kind of like a senior pen tester would do. So at the top level, if you think like an elite security team, this can be seen as a multiple specialized agents. They work together under an orchestrator. So they share memory, they collaborate, and this can uncover complex multi-step attack paths at scale. So let's take a look at our solution at high level. What is it? We call it an agentic AI red team engine, which delivers truly context-aware validation. So what does it mean? We've used three main inputs. One is the target profiling of your application. So we automatically detect your tech stack, assets, expose endpoints, and so on. Then we can also take a user-defined objectives and rule of engagement. So what do you want to test? What do you want to avoid? What are your business goals? And finally, also have an updated knowledge of the threat intelligence. So the latest CVs, the latest attacker techniques, and so on. So the engine function by blending these inputs and creating a dynamic adaptive testing strategy that evolves and learns as you learn more information about your target and you want to and the engine starts continue by achieving the goals that you have defined. So as an output, you have a prioritized list of findings, which are based on the real business impact, as well as a clear visualization of the attack path and also actionable remediation guidance that you can implement right away. So let's take a look under the hood what's going on. So what are the main components of the engine? So five main components. One is the orchestrator agent. And this is like our strategic brain. It sets the goal, plans the attack strategy, and coordinates all components. Then we have the tool management agents, which selects the right tool at the right time and configure them in real time. It communicates with a set of MCP servers, and this is kind of like a gateway to the extensive plugin ecosystem that we have. And we also have the specialized AI agents. These are like domain experts, like privilege escalation agent, PII exposure, and so on. So each of these agents plans and executes autonomously, and then feeds the results back to the knowledge base and so to the orchestrator. The knowledge base is what at the core of our platform. This blends both contextual findings, so from the target, as well as rich deep domain expertise. We maintain a vectorized memory so we can enable semantic reasoning. So the agent can connect clues even if signals don't match exactly. And this orchestration, this loop runs in a loop continuously. So you can imagine the orchestrator that sets an intent, the specialized agent investigates, the tool executes against the target, and the knowledge base keeps learning and adapting and evolving continuously.
Yeah, can you elaborate a little bit more on contextual findings? What exactly you mean by that?
So yeah, so what we want to keep our platform generic enough, but then these contextual findings is everything that you learn in a runtime and from the target that you are that's your objective that you want to penetrate, right? So this target provides you with any contextual finding you can find. You can think about the endpoints, your tech stack, anything that you really can understand from the target as the agents are running tools and gathering knowledge.
Okay, so is it fair to say that we will just keep collecting various data points about a given asset, a given target, and then at some point later, you can start connecting those dots. When you're doing some reasoning, you can connect the dots and then draw various conclusions at the right time.
Yes, yeah, that's a good point. It's not like more like later or before. It's like it all runs continuously at different level of abstraction, basically, right? So at the bottom layer, you have the agents running tools, right? You have the output of the tool, which is huge, and then you have to parse this output and build more abstract level reasoning. So and then as you move up of this abstraction layer, you start seeing like coherent traces of like what the agent is doing and why is it doing it. And as you see that, also the agent can put together different level of insights and come with the elaborate strategy. So it's something that goes in different level of abstraction as well as different moments in time as you gather more knowledge.
Very good.
Okay. So to see the framework in action, let's see a real world weakness, which is this JWT algorithm confusion. So in this vulnerability, the attacker forges valid tokens by tricking the server into using a public key as a secret, basically. And the process is composed of four main steps. First, you obtain a public key. Yeah, you edit the token claim, elevating your roles, for example. You recreate the forged token, and then if the server is misconfigured, you gain unauthorized access. Sorry. So this impact obviously can be dramatic, as you can enable privilege escalation and complete authentication bypass. This is not only a theoretical vulnerability. We've seen this vulnerability in the real life, as it's been hit widely used library in production. For example, you had here some of the main breaches that the causes included a maximum security flaw in Microsoft Azure and Auth0, which affected thousands of enterprise customers. And also cases where a single library bug in a JWT affected over 22,000 projects. And this demonstrates how this weakness can cause widespread platform-wide compromise. So before the demo, here's what you're going to see. So at the input of our agentic platform is only two inputs: the target URL and the low privilege user credential. So with this credential, you can only see the user can only see its own data, and so definitely doesn't have admin rights. So then we have four agents acting together: the orchestrator that sets the goal and coordinates the run, the recon agent that maps the application, so endpoint and the auth flow. Then we have the EDOR agent. So we have two domain experts: the EDOR agent, which checks whether one user can access another user data, and a privilege escalation agent, which the other domain expert, that tests the vertical escalation. So can the user escalate the privilege and gain admin access? So the agent trying together to gain access to the admin panel using the non-admin credential as an input, and if it's misconfigured, our agentic system automatically detects it and uncovers the weakness and exploit it.
So I want to just recap, make sure I'm getting this correctly. So we have four agents in this demo. We have the orchestrator, of course. We have a recon agent. And then EDOR focuses on horizontal privilege escalation, one user accessing another user's data. And privilege escalation agent focuses on vertical privilege escalation, one user gaining admin privilege. Is that correct?
Yes, that's correct, Tom. Basically, one is horizontal and one is vertical escalation. So that's
Very
what
good.
we're saying. Yes. So here you can see how the demo works. So yeah, so first we launched our target environment, which contained the misconfigured server. And as you can see, if you try to access with the, in this case, employee data, so low privilege, if you log in, you only have access to your documents. In this case, this employee of this corporate. So the admin panel is definitely not accessible with your credentials. Now we start. First, we launch the gateway, which orchestrate all our MCP servers. We contains all the tools. Here you see some messages being changed to the broken system to this very basic UI that we built some time ago. And yeah, here you can see how we start with the recon agent that starts calling tools and mapping the application endpoints. Here you can see some of the messages that have been exchanged by the agents. And if you want to take a look at the logs in real time, you can see how the orchestrator started with only the username and password that we used as well before to show the limited credentials capabilities. And then if you fast forward to the completion of the run, you can see all the information has been gathered by all the agents. And let's visualize that in a more pretty way. So here you can see how the agent found the vulnerability, and it connected to a known CVs And here you can see the two domain expert findings. The previous escalation, which provides all the evidence that it found, the public key that has been used, and all the steps to reproduce the vulnerabilities. But also the other agent, we didn't find the horizontal escalation. It provides the evidence why he thinks that is the case. You can see the attack surface that's been mapped by the recon agent. And here you can see some of the messages that have been exchanged by all four agents. And yeah, if you want to take a look at the results, we can also reproduce by following the instruction of the agent exactly how would we gain basically admin access. So if you log in as before as a low privilege user, in this case, Mike Wilson, an employee, then we can see we still don't have admin access by following the instruction of the agent. Here we basically substitute in the session cookie with the cookie that's been forged in real time by the agent. So it took the token, understood the context, because you need to understand the roles and how to modify that, and it forged a new cookie which can just plug in into our browser in this case and validate that the findings has actually been correct and gain admin access.
Very good. So we see that Mike is able to access the admin panel now.
Yes.
Excellent. So let's now switch gears. I'm going to walk through the details of a benchmark bake-off that we did. So let me start by talking about the DEF CON event. Those of you who attended DEF CON a few months ago in Vegas, you probably remember a great session which was titled Leveraging AI for Smarter Bug Bounties. So during this session, a large number of web pen testing benchmarks were shared. And you can see the list of them here. In fact, this is a slide from that session. So what we did afterwards is we took we took a close look at the benchmarks, and we identified the benchmarks that required the kind of contextual awareness that Pierre was talking about when he was going over the engine. So we excluded those from our test. And then we took everything else and we decided to actually use our existing product offering, our RidgeBot, the AI-powered security validation platform, to perform a benchmark. So you see on the left, those benchmarks that require contextual awareness. Some examples are here, such as the JWT that Pierre just demoed. And then on the right side, you see the remaining benchmarks. For these, we use our current product to perform a benchmark, to perform a complete testing. So in addition to our product, we also used Burp Suite Professional. We use the exact same set of benchmarks. That means the same targets were used in our product in RidgeBot as well as Burp Suite Professional. And then also Expo, who published the results of the benchmarks, we took the information from them, and then afterwards we compared the results. So here I'm just showing you what we did in the installation of RidgeBot. So for each given benchmark, we created a pen testing task. You can see the list of tasks here. So there are meaningful names such as Offensive Security Benchmark 85. And then you can see the tasks are running here. Some tasks have already completed. Again, for each benchmark, we created an individual task, and each one has its own unique target. And we let them complete. We did the exact same thing in Burp Suite Professional, which is what you see here. So again, for each benchmark, we created a unique task and we let them complete. So here you can see the end result of the RidgeBot test. You can see the tasks have all completed, and we captured a summary of the result in a health score that you can see right here. So basically, that's the summary. And exact same thing we also viewed in Burp Suite Professional. You can see the list of all the completed tasks. And then for each one, you can see the findings listed in the middle. So again, it's a long list, one entry per benchmark. So now let me just take a couple of examples. I will start with benchmark number 37, which is a command injection benchmark. So we were able to detect an IP address command injection. We actually categorize it as remote command execution, RCE, and then the evidence we provide for it is a screenshot that shows we were able to execute ls-l and also who am I using HTTP post. So that's the evidence that we provide for it. If we look up the exact same benchmark in Burp Suite, you can see that a number of findings are there, but that most important findings was missing. That RCE was not detected. We look at another example, benchmark number 83. So this is a SQL injection vulnerability. We were able to exploit it, and we have a very nice evidence for it. The evidence is, of course, the name of the database table and the name of the database and the list of database tables. If we go to Burp Suite, you can see that, again, some findings are there, but the SQL injection, unfortunately, was not detected. And we look at one other example, which is benchmark 100. This is a GraphQL API vulnerability. We categorize this as unauthorized excessive data exposure, and this is the evidence that we provide. We are showing the type of data that we were able to get, such as the email, etc. So here is the result, the end result of our benchmark. You can see Burp Suite was able to successfully complete 38%, to detect 38% of the vulnerabilities and exploit 38%, and then Expo 82% and Ridgebot 88%. Now, I just want to make a comment here that these are a subset of all the benchmarks that I showed earlier. So only the ones that do not require contextual awareness. However, having said that, with our new platform, we are confident that even this remaining 8%, we will be able to complete.
Yes, that's correct, Tom. Here are some preliminary results of our Genti platform. You can see here just the Expo contextual targets, so those 8 plus also the other one which were not included in this benchmark. We're able to exploit all of them. And you can see here some of the percentage of the run completed, so meaning without errors across all runs and all agents that we have it done. So this is just an average statistics, and 40% means that 40% of the time we're able to exploit it. So if you run it multiple times, you're able to find exploit at least one time. So this is just an average statistic of all the runs we ever done. And here at the bottom, you see the performance of the models, the base model that we're using, specifically the Gemini series and the OpenAI 4o Mini or 4o and Anthropic one. Again, across all runs and all targets. And you can see here we divided into two metrics, basically, two simple metrics, exploit rate and recon rate. So was they able to exploit the target? And was the agent able to do a recon of all the endpoints of the targets, basically?
Very good. So actually, I want to see whether the conclusion that I'm drawing is correct. So Pierre, help me out. So you said that when we have multiple runs, we get slightly different results. So this to me sounds very analogous to a human tester who is coming up to speed by performing various pen testing and perhaps going through a security breach and learning more and more as time passes. So what the agents that we have, it kind of has a similar feel to it. Is that correct?
Yes, yeah. There are so many moving parts that constitute the agent. So you can it not only is by default a non-deterministic system, the LLM itself. According how you set the temperature, for example, you can have different results, but as well as how you orchestrate the agent and what is the memory and the knowledge that you gather. So across different runs, even with the same inputs, you could have different outputs. So that's why it's important to run whatever agent you're building. You run at least a different number of times, and then you, based on the data, you understand, okay, how many times you run this agent in order to get some results.
Very good. Very good. So Let's look at one other thing. So regarding the benchmarks, as I said at the very beginning, the benchmarks only have to do with website and web app vulnerabilities and also API security. But there are many other areas. So our platform, our security validation platform, Ridgebot, covers all of them. So in addition to website, web apps, and API security, we also have network penetration testing, covering wide range of assets, targets such as Windows and Linux servers, network devices like your firewalls and load balancers and routers, OT and IoT devices, applications, your traditional client-server applications, databases, management applications like SSH, SFTP, etc., and also AI infrastructure. We have posted a number of blogs recently about the vulnerabilities that now we're able to detect and exploit in Olama server, in Anthropic MCP server, etc. So I would like to summarize everything. What we currently have in Ridgebot, the current release of Ridgebot has AI-powered smart decision engine. We are evolving that to an agentic AI red team engine, as you saw the demo. Also, we are evolving from automated security validation to autonomous security validation. We are, in addition to detection of known vulnerabilities that we've had in our product, now we are also able to detect zero-day vulnerabilities. And then we've always had zero false positives in Ridgebot. Now we can also say that we will have fewer false negatives. So before we open it up to Q&A, I just want to ask a question to Pierre. So Pierre, can you help us understand why we are able to detect zero-day vulnerabilities now, now that we have the AI red team engine in place, the agentic AI red team engine?
Well, basically, the machinery to detect known vulnerability and novel one is the same. So like with the same machine that you're able to adapt known vulnerabilities, and so having fewer false negative, the same machine can by default discover novel vulnerabilities, because whatever is your target profiling, whatever knowledge you gather, you can connect those dots based on previously known vulnerabilities, but also novel ones. So the machine is the same.
Got it. Very good. So, even though our focus is not going to be detection of zero-day vulnerabilities, but we are very happy that this ability is now built into our new framework. So with that, I'm going to turn it over to Mansi to see, to go through the list of questions that have been submitted.
Thank you, Hom. Thank you, Pierre. Feel free to leave any questions you may have in the chat or in the Q&A section. We'll leave 1 minute to see if anything comes. So I think there are no questions. Thank you, Hom and Pierre, for the great insights. Yeah, so I have a few quick reminders before we close, if no one has any questions. So we'll be sending a follow-up email with the webinar recording in case you want to go back or share it with your colleagues. Also, this email will include a demo scheduling link in case you would like to schedule a short session to explore whether Ridgebot fits your strategy for 2026. And lastly, we invite you to follow us on LinkedIn to stay updated on our upcoming webinars and masterclasses. I see there's a comment in the chat. Yeah, we'll be sending the recording by email. Now, let me see the Q&A section. What is the difference between automated pen test versus autonomous pen test?
Pierre, do you want to take that?
Yes. Okay. Then, yeah. Should I go for it? So basically, automated pen testing, it's like it acts on the fixed strategies, right? So you have a script, you have some fixed knowledge that you want to automate, And so that lacks the autonomous aspect where you don't have the adaptability that with automation, you don't have the adaptability that comes with the autonomy, right? So whatever strategy you have, you still have to be able to manually, define how you apply the strategy to a target, and then you can automate that. With autonomy, you have the adaptability that comes, for free, basically. The agent is able to autonomously adapt any strategy.
Thank you, Pierre.
Very good. Yeah, I also want to add a little bit to that. So with our current solution, which is an autonomous security validation solution, we can say that our solution requires human in the loop. In fact, we do have a feature in our current product offering where a human tester can examine the attacks that have been created but not executed by Ridgebot, and they can actually validate, they can approve them, and then they ask Ridgebot to proceed with that. Moving forward with autonomous, we are switching from human in the loop to human on the loop. That means human testers will still be in the picture, but they don't have to monitor at a detailed level what's going on. They let the product do its work. And then, of course, they will be on the loop so they can, for example, look at the report, and from time to time, they can make some configurations here and there. So that's going to be a major shift that we see happening in the industry. There are many solutions out there that are evolving from human in the loop to human on the loop.
Perfect. Thank you, team. I think there's another question. What kind of data do you guys train Ridgebot on? Is it just on vulnerabilities or data in the wild? Thanks.
Here, do you want to take that one?
Yes. So we are currently exploring a variety of benchmarks. So that's the data that we are learning from, and it's important to have a variety in place. So everything that we learn from the environment, from different benchmarks, then we have to be able to generalize so that we can apply also in the wild, right? So in the training process, or in the phase where we learn, you know the answer, right? So you know the solution to exploit, and that's what we've been training on. So the variety of benchmarks available online, like Juicy Shop, Expo, and others, and as well we are building our own machines so that we can, target machines, so that we can understand even more complex attack paths. So that's the data that we are collecting in a training phase, where we evaluate our agent towards these known targets and towards the target that we're building, so that in the run time phase, so when the agent is, as you said, is running in the wild, the thing that we generalized are applicable to any target that is unknown. Does that answer the question?
Very good. I'll just add one point also. We will continue to consume threat intelligence information also. So that would always be in the picture. That's an important part of our current product offering. Yeah, so that will continue to happen.
Great. There's another question. Do you see hallucination of LLM during your research, and how to avoid?
Yeah, that's a good point. We've seen less and less hallucination as our platform is like this operating system that we are talking about. So we are, on one hand, we're able to switch model and get better models with less hallucinations with no effort, basically, because we're building around the model. But on the other hand, hallucinations are really not a problem, because everything or every hypothesis agents comes with, it's validated always with tools and with real data. So if the hypothesis is not correct, the tools will prove it wrong. So that's how you avoid hallucinations by having a tight integration with the data, with the tools, and the tools are a big part of the engine.
Perfect. Okay, so I think that's it. Great. I also want to mention that we'll be hosting an AI security masterclass next Thursday as well, focused on automating pen testing across enterprise. So I'll share the link to register here in the chat. And I also want to thank you all for attending this session today. Thank you, Pierre. Thank you, Home. And we'll see you, I think, next year as well in our upcoming webinars.
Thank you, everyone. Bye.
Thank you. Have a good day. Bye-bye.
Have a good day. Bye-bye.